Hello, Algebra 1. How's it going? Well, today we're going to look at 2.2 Part A. And we're going to start looking at linear functions. So previously we learned about what functions are.
Evan Lane to the front office, Evan Lane to the main office.
And it turns out functions can be discrete data. They can just be points, but they can be curves. They can be all sorts of things. They just have to pass the vertical line test. Each input has to have exactly one output. But today we're going to focus on linear functions in particular. And we're going to learn to identify linear functions from graphs, tables, and equations. We're going to cover all those today. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b. Okay, and so the key is that y and x are variables. They can be lots of different numbers. And m is going to be the slope and b is the y-intercept. So these are like actual numbers, but you're going to have an x and a y. And it's just going to be a plain x and a plain y. You don't even have to have both of them. As long as you got an x or as long as you got a y, you're going to be a linear function. It turns out when you do some things to the x, or to the y, as a matter of fact, it can mess things up and make it not linear. If it's just a plain x and a plain y, they're not multiplying with other x's or other y's. There's no squareds, there's no square roots. If it's just a plain x and a plain y, there's no division of x or division of y. It's going to be linear. It's going to be linear, okay? So to identify linear functions using graphs, well, here's the thing. The root word for, so you're going to have plain x's, plain y's. The root word of linear is line, and class, just to be clear, a line is going to be perfectly straight and extend out forever. And actually you can have data that's linear that doesn't extend out forever, but typically you're going to have arrows on the ends of your lines. So does the graph represent a linear function? Well, no, this is not. So not linear. And basically, if you're looking at a graph, if it has curves, no curves allowed. No changing, no angles. You know what I mean? No curves, no angles. It's got to be a straight line. It's got to be straight. So part B, that's a linear. Yeah, that's a linear function. And because it's a straight line. So that's how you're going to check for if a graph is linear or non-linear. Is you're just going to look at the graph and then decide from there. Well, you can also figure out if data is linear or not by looking at a table of values. Now, you could certainly graph these and then look at the table of values to determine. But it turns out if they're giving you a consistent data, if they're giving you regular data, then you should be able to tell by looking at certain patterns if it's linear or not. For example, on this data, you can see that the x's are going up by 3 each time. So they're adding 3 each time. That tells you that it's nice, consistent data, okay? It's fine, it's working. But just because it's fine and consistent data up top doesn't make it linear. So we want to look down here and see what the pattern is down here, if there is a pattern. So you do have to check the top. So far we're good. And then at the bottom, the pattern is, let's see, it appears to be that they are subtracting 6 each time. All right. So this is linear. And you can tell it's linear because it's got to have consistent addition or subtraction. Consistent addition or subtraction will make the data, will be evidence that the data is linear. Now be careful here, because in the math world, you could have consistent multiplication, you could have consistent division. Okay, so you want to double check. As long as it's consistent addition or subtraction, it is in fact linear. And this makes sense. Like, so for example, I was telling you, y equals mx plus b, you're gonna have a slope and a y-intercept. Well, we can see this, this consistent addition and subtraction is slope. So for every 3 that they go over, they're going down 6. So rise over run. The slope is -6 over 3, or -2. So you can actually see the slope by looking at the consistent addition or subtraction. So this is linear. And for part B, let's see if we're going consistent across the top. And we are, we're adding 2 each time. Now let's see if we are consistent across the bottom. Let's double check here. To go from 2 to 9, we would add 7. And then from 9 to 20, we would add 11. And you can see right away that it's not consistent. And since it's not consistent, it is not linear. Okay, not linear right there. Well, the other ways, and again, there might be a pattern, but if it's not a pattern of addition or subtraction, then it's not linear, it's something else. Well, for example, 3, identifying linear functions using equations. If you just got an equation, you're gonna look for plain x's and plain y's. You're going to look for things that can be rewritten in slope-intercept form, y equals mx plus b. And this one right here, it's got a plain y, and it doesn't have an x. Well, you know what? That's okay. What that means is that the slope was 0. But we can totally write that in slope-intercept form. So we got a plain y. This is totally linear. If you just have an x, it's going to be linear. Turns out if you just have an x, it's not going to be a function. It's not going to pass the vertical line test, which is interesting. That may show up on your homework, actually. But if it's just a y, you're good. It's going to be a flat line is what it's going to be. Now, a square root of x is kind of a cool graphic. It does this. And if you notice, it's curved. So yeah, it's not an ordinary x. It's got a square root with it. So this is non-linear. Oh, if you have x as an exponent, that's an interesting graph. It's going to look like this. Notice it's curved. So anyway, that is non-linear. This is, now be careful on these that have parentheses. Go ahead and distribute it first. And notice you get 6x minus 6. That's just a plain x, plain y. We're good. It's linear. But be careful on these, because sometimes you'll have an x right here, and if you do x times x, you'll get x squared. And x squared is not an ordinary x. An x squared is going to be like a U shape. And well, yeah, look at our next one. See how you got a normal y. The y is not, they don't have to be solved for. They can have lots of different numbers and stuff. But as long as it's a normal y and a normal x, you're good. But this is not a normal x. This is x squared. It turns out if you graph this, it would be like probably going up like that. It'll be like a U shape, but clearly curved. So this is non-linear. But yeah, you want plain x's, plain y's. That's all I got for you. Thanks a lot.